For this circuit we need to find the current I here and the voltage drop V here. So what we notice about the circuit is the resistances, the values of the resistors are actually not in terms of resistance but in terms of conductances. So this, the S means Siemens or mho, if it can be said as mho or Siemens. So we have to use them as conductances in your calculation. So what we first notice is these two are in series, and when two conductances are in series, the formula goes like this, like resistances in parallel. So it will be like that. So equivalent one will be 6 times 3, 18 over 9, which is 2. So we will have the circuit like this. So this is 2s and this will be 2s as well, and this is 1s, this is 4s, like that. Now these two are parallel, and when they are in parallel, what happens is the values are just they just get added. So this one becomes 4, because when two conductances are in parallel, the formula is like that for two resistances in series. So 2 plus 2 is 4. So I will replace them with one resistance and just write 4 here. So that's 4s now. Then again we have this 4s and this 4s in series. So what we will have now is 4 times 4 over 4 plus 4. Basically two two conductances in series means like the formula will be like two resistances in parallel. So same value, so it will be just half. I will just write directly the half value. So now what I have is like this. So this one will be just 2 Siemens here, and this is 1 Siemens, and this is 9 amps here. So the current that we were interested in is this current, and this is still the same current because we have we actually had previously these two, sorry, here we had 4s here and 4s here, and I have just replaced those two conductances by 1, but it's still the same branch, so the current is still the same. So what I will do, I will leave it like that, and we need just this I. So we have two parallel paths and we need to find just the current here using current divider rule. So what I will do, the current I will be 9 over. Now since these are not resistances, these are conductances, the rule will be bit different. So we have the denominator as same, addition of the two conductances like the resistance, but when I multiply, I am calculating this current and I will multiply by the same branches conductance. If it were resistance, I would have multiplied with the other one, the other branch's resistance, but since it is conductance, I will multiply with this one, which is 2s, the same branch, the conductance of the same branch. So it's multiplied by 2, so this is 9 over 3 times 2, which is 6 amps. So this current is 6 amps, that's fine, and total current was 9 amps, so this current will be 3 amps, and the voltage drop, which is plus V, will be 3 times, basically voltage drop will be actually, so this is V, and we have I here, and this will be over G because it is conductance. So this will be 3, which is the current, over G, which is 1, so that's 3 volt. So if it were resistance, we would get the same result, but we have to remember that this is conductance, so we are actually dividing in this case. So when the values are given in conductance, we have to be very careful about using the formula, various formula, and otherwise what we can do, we can actually convert everything into resistances, but we should learn the way to do using conductances as well.